My name's Chris Davis. I'm a space scientist and I'm working on a mission studying the Sun. So I've been asked to show you my top 10 images of the Sun. This is a movie taken by the SOHO spacecraft. There was an eruption on the surface of the Sun. I mean, you can see this is the solar surface zoomed right in, but it's being observed in extreme ultraviolet light. So this is very, very hot gases in the Sun's atmosphere. And as the Sun rotates round, this complex region of magnetic fields here spits out a violent cloud of particles, which you can see zapping the detector of the cameras. And it rotates a little bit further. Again, there's another great big spout of particles. This eruption actually went on to cause a spectacular auroral display at Earth and caused all kinds of interactions with the atmosphere and spacecraft. And it's considered to be one of the definitive events in studying how the Sun can affect the Earth. This is the first image that I saw from the Stereo mission, where they had combined views from both spacecraft to create a three-dimensional image of the Sun. It's one of those images you need to have the red and green 3D specs on to see properly, but when you do, the whole thing comes out and comes alive. You see the Sun as a sphere for the first time. Stereo is a mission with two spacecraft moving away from the Earth in opposite directions, and for a window of opportunity early on in the mission, you had a perfect stereoscopic view of our star, and that was a revelation to me, to see the star as a spherical body for the first time. In 2004, we actually witnessed a transit of Venus across the Sun. This is where the planet Venus moves between us and the Sun, and it appears as a tiny little black dot on the surface of the star. And this doesn't happen very often. The alignment of the planets has to be such that it actually crosses the disk. And at the Rutherford Appleton Laboratory here, we had an event where we set up a telescope. We had, in the classroom behind us, I think the lecture theatre behind us, we had something like 100 children who were sat watching this, and they sat transfixed in silence as this little dot moved across the surface of the Sun. And as it left the other side, they all applauded. It was really sweet. So that was a really interesting event for us, to actually see another planet. And it makes you realise the relative sizes of these things. Venus is a planet not much smaller than the Earth, and it just is dwarfed by the Sun in the background. The whole purpose of the cameras that we run on Stereo, the heliospheric images, or HI cameras, is to look at the solar wind. And this was the first unequivocal solar storm that we saw launched from the Sun heading towards the Earth. So on the right-hand side here, you can see a storm being launched, and it crosses from the inner camera through to the outer camera. It washes past Venus, and then this is our planet here. And the reason we want to know about this is that we want to protect our ever-increasing investment in space and ground-based technologies such as power grids. This is a picture of a sunbeam. It's light scattered in the camera optics of this particular spacecraft, and there is a very little blue dot in this particular sunbeam, and that blue dot is the Earth. That is a picture taken by the Voyager spacecraft at a distance of 6 billion miles from the Earth, and it was the idea of Carl Sagan to actually look back at our planet from the furthest distance that we'd ever reached at that point, and just contemplate that everything we ever knew was in that tiny little blue pixel. This is a picture that I took. It was an annular solar eclipse, and it occurred over southern Spain in 2005, I think. An annular eclipse is where the moon isn't quite as big as the Sun in the sky. The apparent diameter isn't quite as big because the moon's slightly further away in that particular part of its orbit. So you never cover up the entire solar disk. So this dark disk in the middle is the moon, and the outer disk is the Sun. I had to put a very heavy and special filter on my camera in order to be able to see this. But even so, there's all these wonderful rings of light that come echoing around inside my telescope optics. And although it may not be a great scientific image, I think it's really pretty. But during the annular eclipse that I went to see in Spain, we witnessed some of the peculiar phenomena that you see during eclipses, and this is one of them. The sunlight shining through the small gaps in the leaves of the trees produces tiny little pinhole cameras, and it generates images of the crescent eclipse just before the disk actually became central. So you have these tiny little crescent eclipses that scatter everywhere. Everywhere there's a tiny little hole that a sunbeam can get through, you see an image of the eclipse. This is an image from the Stereo spacecraft, again, from the heliospheric imager. So the sun's just off the right of this picture, and it was one of the first CMEs, this is the coronal mass ejection, a solar storm, erupting into space, and I think it shows the fantastic scale of these storms. This is the planet Mercury, and this is the planet Venus. It's quite a scary prospect to be sat on Mercury at the best of times, but when you've got a storm that's a billion tons of material whizzing past you at 1,000,000 miles an hour, really must be quite a daunting prospect. This is an image of a sunspot that I took with my little telescope in the back garden. I've got a filter I can put on the end of my telescope to enable me to view the sun with it. The sun's been really quiet, really inactive, and you can see that it looks almost completely blank, the disk. But just down in this bottom left-hand corner, there's a couple of dots, and these sunspots are an indication that the sun's magnetic fields are starting to wind up and get active again. So this was one of the first indications that the sun was finishing this long sleep it had had and was actually starting to wake up and do something interesting again. Each sunspot's about the size of the Earth, so they're not actually very small, but in comparison with the vast disk of the sun, they do appear to be tiny little regions. So the 10th image is something that a colleague of mine published recently, and I think it's an amazing image. It's the first image ever recorded of a sunspot in the literature. So to follow me, we'll head to the library and dig it out the shelves. So in here is this. This is the first ever recorded picture of a sunspot, and it was recorded by John of Worcester in 1128, on the 8th of December. This is his drawing of the sunspot, and he said he saw a large spot to the top and a small spot underneath, and he tried to draw what he saw. So he's the first person that we know of to actually draw a sunspot. This is the journal of the Royal Astronomical Society, known as Astronomy and Geophysics.